this time we talk about rotation. Okay, and rotation, usually we need to tell people the direction of your rotation, and then first let me show you how to rotate clockwise. Clockwise means we follow the direction of a clock. Okay, if imagine, okay, if you think about the minute hand in the clock, uh, normally it move in this direction, and therefore if I rotate something, okay, in this direction, we call it clockwise. And then if you think about the case in the clock, um, there's a pivot here, okay, for the minute hand, and then in this case, it is actually a point. Okay, in this example, we're about the origin. Therefore, it means this point is the origin. Okay, and then how far it move, or the angle of this movement. Okay, and then we first look at 90 degrees. Okay, in this example. Now, take this one. It is 3 5. Okay, it means we start from this point. Okay, and then we want to rotate this point, okay, clockwise about the origin by 90 degrees, and then we would like to find out the new position for this point. Now, first I would like to plot the point here in the graph paper. Okay, 3 5 is here, and then roughly speaking, it is a problems like that, and then this point rotate, okay, rotate, okay, in this way. Okay, and we can make it clear, okay, if I copy it into a piece of tracing paper. Okay, right. I'll copy the axis. Okay, and then this is the pivot. Okay, and then this is the point is here, and then I would like to join the point with the origin like that, so that it looks like the minute hand in the clock. Okay, therefore when we have rotation, it means you fix this line at this point and not moving, and then this is rotation. Okay, try to keep this point in the position, and then therefore we just move in this way. Therefore you can see we are looking at the movement of this one. Okay, and then about the origin. Therefore if I join the line here, then you can see clearly, okay, this is the distance between, okay, the origin and this point. And then if I do a rotation, okay, the distance here is kept unchanged. Okay, just like when you are using the compass to draw a circle. Okay, then this is called rotation. Okay, right. Now, if I want to move it, okay, like that, clockwise, okay, and then this movement is clockwise, and then therefore it means I imagine, okay, I want to move this line, okay, move this line, and then for 90 degrees, okay. Now if I don't have a protractor, okay, it is quite difficult, it seems difficult to measure the angle for the rotation. But if we look at our coordinate plane, okay, this is x-axis, this is y-axis, and then actually if we look at here, the angle here, this angle is a right angle, and that's similar for the other three regions. Actually, okay, each angle here is a 90 degrees, because if I start from here and then come back, it is a round angle, and then these two axes, okay, cuts the angle into 4 equal parts. That's why each angle here is 90 degrees. Therefore, it is very easy, okay, if I look at y-axis, okay, imagine if I have y-axis, if I have it move to this direction, I know that it is 90 degrees, 90 degrees. Now, therefore, in this case, therefore, I can take this one as a help, okay? That's why I copy the x-axis and I copy the y-axis. And then now, okay, I want to rotate, okay, clockwise, okay, in this direction by 90 degrees. Therefore, everything, okay, everything rotate, okay, 90 degrees. Therefore, how do I know I have moved 90 degrees? Okay, when I have this line, okay, cover x-axis, because this line, okay, if you still remember just now, okay, it represents the original y-axis. Okay, after rotating it, okay, clockwise by 90 degrees, okay, this line should overlap with x-axis. Therefore, I know that I have rotated 90 degrees. And therefore, if I look at this point, then you can find out the new position after this rotation. Okay, the x-axis is 5 and y-axis is -3. And therefore, if I rotate 3, 5, okay, clockwise about the origin by 90 degrees, the new position is 5, -3. Okay, now let me try another point. For example, maybe -4, -6. Okay, and then look at the graph paper, and -4, -6 is here. Okay, and then I will get another piece of tracing paper. Okay, and then I will copy the axis and then this part. If you're afraid that you'll forget which one is x-axis, which one is y-axis, you of course you can label it. Okay, this line is y-axis, and then this line is actually the x-axis. Okay, and then I join the points of the origins like that. Okay, therefore I'm looking at the position of this point, okay, after the rotation. Okay, we'll do one more clockwise rotation. Clockwise means rotate in this way. Therefore, in this case, it means you keep this point and move, okay, and then you move, okay, like that. Okay, this is the original x-axis. Okay, after it has moved 90 degrees, okay, it should overlap with y-axis. Okay, then you know that you have moved or rotated, okay, 90 degrees clockwise. Okay, therefore this is the new position of the points after rotation. Okay, this point. Then you can read the coordinates here. X coordinates is -6 and y coordinates is 4. And therefore it means if I start from -4, -6, okay, after I have rotated it clockwise about the origin by 90 degrees, the new position is -6 and -6 and y coordinate is 4. I will suggest you to try a few more examples by yourself and then see whether you can find a pattern of doing this kind of exercise or this kind of problem. Then we have a quicker way to figure out the new position of the coordinates without drawing the points on a piece of graph paper. Okay, you can try this by yourself first.